Hello everybody, in this video we're going to talk about how to solve a 3-variable system of linear equations where we have one solution. So before we get into the example, let's talk about the steps that we need to take to arrive at our solution. So step 1, we want to rewrite the linear system in 3 variables as a linear system in 2 variables. So basically we want to use substitution or elimination to get rid of x, y, or z so that we can go from 3 equations with 3 variables to 2 equations with 2 variables. So once we have that, now step 2, solve the new linear system for both variables. So now it's kind of like what we did in Algebra 1 where we just have a 2 equation, 2 variable system, and we can eliminate or use substitution. Probably most of the time you're going to use elimination, but that'll give us what one of the variables is equal to. Once we have one of the 3 variables, step 3 says substitute the value from step 2. So once we get one of our variables, we could substitute that back into one of the 2 equations that we had in step 2. And now that gives us 2 of the variables, and then we just pick one of our original equations, plug the 2 variables we have in, and that'll give us the 3rd one, okay? A couple things to note, and we're not gonna see this in this video, we will in later videos, but when solving, if your variables cancel out and you are left with an equation that is false, such as 0 equals 1, then there's no solution. Very similar to when we had just 2 equations with 2 variables. Same thing when our variables cancel out, but we're left with something that's true, so 0 equals 0 or an identity, then there would be infinitely many solutions, okay? Well, in this video, we're gonna focus on what does it look like when there is one solution. So here's our 3 equations. And the first thing I'm gonna do, remember with systems, especially if we're using elimination, we can multiply our equations by anything we want, and we can multiply any equation by anything we want. We don't have to multiply the same thing by both equations, right? As long as we multiply everything in the equation. Well, we can also divide. So if I look here at these equations, I'm going to take the first 2 equations, I'm going to divide those by 2 just so I can work with some smaller numbers. And the last equation, I'm going to divide those by 4. So our new equations are going to look like this. We're going to have 3x plus 4y minus 3z is equal to 31. The second equation is going to be 5x minus 6y minus 7z equals 7. And the third equation we're going to divide by 4. So we're going to have 3x minus 2y plus 5z equals, and we can do 68 divided by 4, and that's going to give us 17. So we have negative 17. Okay, so now I'm going to take 2 of my equations. I'm going to try to eliminate one of the variables. Well, if I notice the top equation and the bottom equation, they both have this 3x right here. So if I write those 2 equations on top of each other and I subtract, it's going to eliminate x. So let's do that. We'll have 3x plus 4y minus 3z equals 31, and 3x minus 2y plus 5z equals negative 17. I'm going to draw my line under there and I'm going to subtract these equations. So when I do that, my x's are going to cancel out. And now we just have to subtract our remaining variables. So 4y minus negative 2y would become 4y plus 2y. Negative 3z minus 5z would be negative 8z. And then 31 minus negative 17 would be a positive 48. Okay, so I'm going to put a star by this equation. That's going to be one of the equations that we can use for our step 2 because we've eliminated one of the variables. Okay, so now let's go back to our 3 original equations up here at the top, and I'm going to erase these 2 stars. And now I'm going to use the equation that we haven't used yet. So 5x minus 6y minus 7z equals 7. And now we just want to eliminate x again. So let's go with the top equation. We could use the top or the bottom, it doesn't matter. And let's write this 3x plus 4y minus 3z equals 31. And now let's look at what we have. Well, if we want to eliminate x, we're going to have to multiply here so that we can create the same coefficient if we want to subtract, or opposite coefficients if we want to add these equations. Well, we subtracted on the first one, so let's just go ahead and subtract again. So I'm going to make these become 15x. So I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 5. So this top equation is going to come right here, and we're going to have 15x minus 18y minus 21z equals 21. And the bottom equation we're going to bring right here, and we'll have 15x plus 20y minus 15z equals 155. Okay, so now we'll take these arrows away and let's draw our line under here, and we're going to subtract now. So x is going to eliminate, that's great, that's what we wanted. And now we have negative 18y minus 20y. So negative 18 minus 20, that's going to give us a negative 38y. Okay, now we have negative 21 minus negative 15, so negative 21 plus 15, so minus 6z. And then we have 21 minus 155, and that gives us negative 134, okay? All right, so now we're gonna take these two equations that we have, and we're gonna write them next to each other in a system. Okay, so now we have 6y minus 8z equals 48, and we have negative 38y minus 6z equals negative 134. Okay, and now we need to eliminate one of these variables, and let's eliminate z because we have a negative 8 and we have a negative 6. And let's make those, let's say make them both be 24, right? So let's multiply this top equation by 3, and let's multiply this bottom equation by 4. So now we're going to have in the top equation 18y minus 24z equals 48 times 3 is 144. And then we have 38 times 4. So down here we have negative 152y minus 24z equals, and 134 times 4, and we're going to get negative 536. And now since we have the same z coefficients, we can subtract these. And so we have 18y minus negative 152y. So that's going to give me 170y. My z's will cancel. And we have 144 minus negative 536. So once again, we can add those. And that's going to give me 536 plus 144, 680. And now we can go ahead and divide by 170. And that's going to give us our y. So divide by 170. And we get a y value of 4. Okay, so all of that work to get a third of our answer. But the good news is the majority of our work is over. Okay, so now let's change up our color here. And now let's go back and let's take 4 and let's plug it into this equation right here. So 6y minus 8z equals 48. Okay, so I'm going to bring it down here on the bottom. So 6, let's change up that color. Let's go to yellow. Okay, so I'll put a box around here. That's the equation we're going to use, and we're going to find z. So we have 6 times 4 minus 8z equals 48. This would be 24 minus 8z equals 48. Subtract that 24. So now we have negative 8z equals 24. Divide by negative 8, and we get z is equal to negative 3. Okay, so now we have 2/3 of our answer. All right, let's go to white here. And now we need to go back to one of our original 3 equations. And we could use one of these 3 because, once again, it's the same thing. But let's just go back to maybe just this middle equation. Okay, actually, let's do the top one. Okay, so let's bring it up here at the top. We do not know what x is yet, so this is 6x plus 8. We do know what y is 4. Minus 6, we know what z is negative 3. And that is equal to 62. So now we have 6x plus 32 plus 18 equals 62. So 6x plus, this would be 50, is equal to 62. And now we can subtract that 50. And now we have 6x equals 12. Divide by 6, and we get x equals 2. Okay? And now, for our final answer, let's write it in purple down here. If it'll show up well, it will. And let's go, now we're going to write this as a coordinate, not pair, a coordinate triple. So we have 2, comma, 4, comma, negative 3. Okay, and that would be our final answer, 2, 4, negative 3. Okay, and that's how you solve a 3-variable system when there is one solution.